Welcome to this video on estimation using proportions. This works very much like when you have a population standard deviation, and you'll get to use z-scores to calculate your intervals. Just a quick review of proportions, and there's some new notation here, so be very, very careful. But if you remember with proportion, we had n trials, or sample size. This was how many times we attempted something, or possibly the number of people we talked to. And R was the number of successful outcomes. So the number of times or number of people we got the result we were desiring. Now, in previous sections, we may have just used P and Q for the probability. P for the probability of success and Q for the probability of failure. But here, where we're estimating P, as we're going to do, estimate a proportion, these notations are used for populations. So what we're going to be given is information about a sample, and that's what comes from up here. We had a sample size, we had a number of successes from that sample. So what we would get from here is actually sample information, and the notation for that looks like P hat, little line over it, and Q hat. So P hat is the probability of successes from a sample, and remember that is desired outcomes out of possible outcomes, and sometimes this is called a point estimate. And Q hat is the probability of failure, okay, from the sample. And here's a sample question that says 1,048 teens were surveyed, and 189 named Fox as their favorite television network. So from that information, we're asked to give a 90% confidence interval for the probability, which is sometimes called a proportion, that a person in this age group would choose Fox as their favorite network. So the sample size, or the number of people we asked, was 1,048. The number that answered Fox was 189, so we can get our point estimate, or our sample probability here, of 0.18. And remember that success plus failure equals 1, so we can say that Q hat, or probability of failure from the sample, is 0.82. We're given a C, a confidence interval of 90%, which means the critical value Z of 0.9 from our table is 1.645. And what we're actually calculating is P, which would be the proportion, or the probability for all teens. Okay, that's going to be an estimate. So the formula looks a little bit different from before, but that's just the way that proportions calculate standard deviation, and it's been manipulated a little bit. So you don't see necessarily where it comes from compared to the other estimations we've done. But you see all the information here that should look familiar from the previous page that we just found. And once again, this part here is called the margin of error, so there's a simpler version of the formula. But be very careful here. Before, where you had X bar for a sample mean and mu, what looked like the U, for the population mean, you've got two P's, so be careful that you can keep them separate. Okay. So here's all the information we had again. Push it in, plug it in and push all the way through. Make sure your calculator, because this could be a little bit tricky here, okay, taking the square root of things multiplied and divided. So make sure you can get this after multiplying by the critical value. But here we get our interval, which means we're 90% confident that the probability of a teen lists Fox as their favorite network is between a probability of 0.1605 and 0.1195. Or, because if we want to look at a proportion, we could say that between 16.05% and 19.95% of teens would list Fox as their favorite network. Thank you.